Kubernetes networking. Okay. In the Docker, we have talked about this NATing rule, the bridge adapter. So when a container is going to communicate to the external world, it will create a bridge adapter, and via the bridge adapter, it is going to do a network address translation, and when it is going out, it is going to change the source IP and all those things we have explained it in that. Okay, but in the Kubernetes scenario, what we are going to have is we are going to have a multi-Docker configuration, right? It is not a straight away single node. I'm not going to run it. So it is not going to work in this method, right? So there is no IP NAT or something. It's going to help me to achieve that. Okay, but here this is going to something similar to it. Okay, I'm going to have multiple nodes. The nodes may be in a different network, like it will have a unique IP address, and I need to have a overlay network configured between these two containers so that they can communicate effectively, right? So this is what the network providers are going to do. Okay, before going into this concept, let me talk about some of the terminologies. Okay, so first terminology I'm going to talk about is called layer 2 networking versus layer 3 networking. Okay, I have talked about the OSI layers. Okay, so the layer 1 is the physical layer where I have talked about these are dealing with the electrical signals. This is where the LAN cable comes into picture, your data is converted. So the data is converted into electrical or light signals, and it will be transferred to the another device where the electrical signal was taken into, and then it will be divided into packet. Okay, this is the layer 1. Okay, the next layer is called the data link layer. So data link layer is something like that. So imagine, let me show that. So imagine there are two machines. Let me say server A with the IP address 192.168.1.10. Okay. Same way, let's say I have a server B 192.168.1.11, and these two are connected to a switch. Let's say I have a switch which connects these two. So let's say it is connected to in switch we have ports, right? Port 1, let's say it is connected to port 4. Okay, so when the network packet is coming out of this, there will be a MAC address associated with every interface. I told is a mission ID. In the world, every MAC address will be unique. That is the assumption. Okay, so there will be a MAC 2. So when the server A wants to communicate to the server B, okay, so the packet will go to the switch, and the switch doesn't have any ARP table. We talked about the ARP table, you remember? So the server doesn't have an ARP table. So what it is going to do, it is going to broadcast the message to, I want to connect to this server 192.168.1.11. Okay. So then the server B is going to respond, this is my MAC address and I'm serving on this IP. Then the switch will update its ARP table saying that, so if the target is 192.168.1.11, I need to forward it to MAC 2. So this will have this routing table. The routing actually happens in the MAC level. Okay, so it will register that, and hereafter, whenever any request comes to 1.11, it will be forwarded to the MAC 2. Okay, this is the example of a layer 2 networking. This is how the network works. Network layer. So this is kind of happen when, see, imagine this server is within the switch. I don't have any issues. I have the MAC address. I'm able to connect, right? Imagine there is a server C, which is not directly connected to the switch. So this is where the router comes into picture. So imagine the situation where I explained. So this is what happens in the layer 3 networking, where when it is going out, okay, this router, okay, instead of this 192 series, let me call it as 200.200.200.200. So this server is not within the switch. There comes a request. This is where the NATing, network address translation, happens, right? And in the packet, this will also have the source IP embedded. That is called as the encapsulation. Okay, this is the another concept I'm bringing in. So when the packet goes out of the network, right, it is going to carry the public IP of the router. So let's say this public IP of the router is 100.100.100.100. Okay, not only the 100.100, it will also carry the 192.168 1.10 IP also. This concept is called encapsulation. Okay, this is where the layer 3 networking comes into picture. So it is like routing the packets from one network to the another network. So these are all the terminologies you need to understand before going into this.